Using ESO's flagship Very Large Telescope, along with other telescopes around the world, a team of European astronomers has discovered the most distant quasar ever recorded. By studying this blazing beacon in detail, the scientists have found that we are seeing this quasar at a time when the universe was just 770 million years old. This means that the light from the quasar took 12.9 billion years to reach us. Never before has a brighter object been observed this far back into the early universe.
This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory, exploring the ultimate frontier with our host Dr. J, aka Dr. Joe Liske.
Quasars are very brilliant, distant galaxies, powered by supermassive black holes at their centers. These amazing objects have the mass of millions of suns crammed into spaces as small as our solar system. Quasar phenomenon transforms ordinary galaxies into what astronomers have fittingly dubbed angry monsters, the most luminous of all objects in the universe. And ESO's Very Large Telescope, better known as the VLT, helped to discover the farthest of these impressive objects ever observed. Back in the early universe, galaxies contained much more gas and dust than we see in them today. Gradually, material was used up in the formation of stars and planets, and less was available to feed the supermassive black hole, the process that creates the impressive jets of a quasar. Objects far back in the early universe, like the newly recorded quasar, cannot be observed in visible light. By the time it reaches our detectors on Earth, the expansion of the universe has stretched the light so much that it falls mainly into the infrared part of the spectrum. In addition, quasars in the early universe are extremely rare, and so in order to find this object in the first place, the team of astronomers had to spend 5 years painstakingly examining huge lists of objects from an infrared survey made by the Ukert telescope, before they finally struck gold. With such an exciting discovery, the team could take no chances. They had to validate their findings. Using the Force 2 instrument on the VLT, along with instruments on the Gemini North telescope, a redshift of 7.1 was confirmed. This corresponds to such an extraordinary distance that it took the light from the quasar 12.9 billion years to reach us. Despite the vast distance, the quasar's extreme brightness made it possible to identify other characteristics using the same two telescopes. It was determined that the black hole powering the quasar has a mass of about 2 billion times that of our own Sun. This is an extraordinary mass for an object so early in the universe. Since current estimates say there should only be around 100 bright quasars at this distance across the entire sky, finding this object was a huge challenge. It was a great bonus that it has proved to be even more distant than the astronomers expected. This quasar is a vital probe into the early universe and will help us understand how black holes grew just a few 100 million years after the Big Bang.
A team of scientists has studied the unusual galaxy cluster Abell 2744, nicknamed Pandora's cluster. Using telescopes in space and on the ground, including the NASA ESA Hubble Space Telescope and ESO's Very Large Telescope, they have discovered that it was formed by the simultaneous pileup of at least 4 separate galaxy clusters. This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory. When huge clusters of galaxies crash together, the resulting mess is a treasure trove of information. Observing these cosmic pileups lets astronomers reconstruct events that have happened over hundreds of millions of years. It also lets them study how different types of matter behave during these collisions. The galaxies in Pandora's cluster are clearly visible in images from Hubble and ESO's Very Large Telescope, but they only make up about 5% of the cluster's mass. About 20% is hot gas, which is shown here in pink. This gas is visible thanks to its X-ray emission, which can be detected with NASA's Chandra satellite. The lion's share of mass in the cluster, about 75%, is dark matter. The dark matter cannot be seen directly and is somewhat of a mystery in modern-day astronomy. But there is a trick astronomers can use to find out its location. By looking at the way that gravity distorts light from more distant galaxies, they can work out where dark matter is hiding. This lets the astronomers make a detailed map of where the dark matter is, shown here in blue. Comparing the location of the galaxies, the hot gas and the dark matter shows that this is not a simple crash between 2 clusters. By reconstructing the history of Pandora's cluster, astronomers think that it must have formed from 4 different clusters involved in a series of collisions over a period of some 350 million years. It seems that the complex collision has separated out some of the hot gas and dark matter, so that they now lie apart from the visible galaxies. Near the core of Abell 2744, the gas of one cluster has collided with that of another to create a shockwave. The dark matter passed through the collision unaffected. In another part of the cluster, there seem to be galaxies and dark matter, but no hot gas. The gas may have been stripped away during the collision, leaving behind no more than a faint trail. Even stranger features lie in the outer parts of the cluster. One region contains lots of dark matter, but no luminous galaxies or hot gas. A separate, ghostly clump of gas has been ejected, which precedes rather than follows the associated dark matter. This puzzling arrangement may be telling astronomers something about how dark matter behaves and how the various ingredients of the universe interact with each other. Galaxy clusters are the largest objects in the universe to be held together by their own gravity, and understanding how they form and evolve is a vital aspect of unraveling the history of the cosmos. Learning more about dark matter not only furthers our understanding of clusters, but it also takes us a little closer to fathoming the nature of this mysterious and elusive substance. A new telescope for mapping the skies is about to start work at ESO's Paranal Observatory in Chile. The VLT Survey Telescope, or VST, with the 268-megapixel Omega Cam camera at its heart, is the latest addition to the observatory. It is the largest telescope in the world designed to survey the sky in visible light. This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory, exploring the ultimate frontier with our host, Dr. J, aka Dr. Joe Liske.
Hello and welcome to the ESOcast. The new telescope is called the VLT Survey Telescope, or VST for short. And the special thing about it is that it has a very wide field of view, about twice as broad as the full moon. It's dedicated to mapping the skies both very quickly and with very high image quality. The VST is housed in an enclosure right next to the VLT unit telescopes on the summit of Cerro Paranal, under the pristine skies of one of the best observing sites on the planet. Now, over the next few years, the VST and its huge camera Omega Cam will be busy making some very detailed maps of the southern skies. And in this episode, you'll get to see the very first released images from this brand new telescope.
The VST is a visible light telescope that perfectly complements the VISTA Infrared Survey Telescope. The unique combination of the VST and VISTA will allow many interesting objects to be identified that can then be studied in detail with the powerful telescopes of the VLT.
The VST is a state-of-the-art 2.6-meter telescope equipped with an active optics system that keeps the two mirrors of the telescope perfectly aligned at all times in order to ensure the highest possible image quality. Now, at its core, behind huge lenses, lies the Omega Cam camera, which was built around no less than 32 CCD detectors, which together provide a whopping 268 megapixel image. Now, the camera also contains some extra CCDs that help with the telescope guiding and the active optics system, as well as some absolutely enormous color filters. Both the telescope and the camera were designed to take full advantage of the excellent observing conditions on Paranal. The VST is a joint venture between ENAF, the Italian National Institute for Astrophysics, and ESO. ENAF, and in particular its Capodimonte Observatory in Naples, designed and built the telescope, while ESO was responsible for the civil engineering works at the site. Omega Cam was built and designed by a consortium of astronomers working in the Netherlands, Germany, Italy, and at ESO.
The VST will make 3 public surveys over the next 5 years. One survey, called KIDS, will image several regions of the sky away from the Milky Way. It will help astronomers understand more about dark matter, dark energy, and galaxy evolution, and find many new galaxy clusters and high redshift quasars. The VST Atlas survey will cover a larger area of sky and will focus on determining the properties of dark energy. Like KIDS, it will also hunt for faraway galaxies and quasars. The third survey, VFAS Plus, will image the central plane of the Milky Way to map the structure of the galactic disk and its star formation history. It will yield a catalogue of around 500 million objects and will discover many new examples of unusual stars at all stages of their evolution.
The data volume produced by Omega Cam is going to be pretty large, with about 30 terabytes of raw data produced every year. Now, these data are going to flow back into data centers in Europe for processing. The huge lists of objects found in the images, as well as the images themselves, will then be made public, so that astronomers from all over the world can use the VST data to help them figure out the answers to a vast range of different astronomical questions.
The VST has just made its first release of images. The spectacular Omega Nebula, also known as the Swan Nebula, is a region of gas, dust, and hot young stars that lies in the heart of the Milky Way. The VST field of view is so large that the entire nebula, including its fainter outer parts, is captured and retains its superb sharpness across the entire field.
Omega Centauri is the largest globular cluster in the sky, but the VST, with its very wide field of view, has no problem in capturing the whole object in a single image, including its very faint outer regions. This image contains about 300,000 stars, and it highlights the impressive sharpness of the VST's images. The combination of large field of view, excellent image quality, and the very efficient operation scheme of the VST will produce an enormous wealth of information that will advance a number of different fields of astrophysics. Many astronomers, including myself actually, are really looking forward to the first results from the VST surveys. This is Dr. J, signing off for the ESOcast. Join me again next time for another cosmic adventure.
The Atacama Desert in northern Chile, one of the driest and most hostile environments in the world. Under the blazing sun, only a few species of animals and plants have evolved to survive. Yet this is where the European Southern Observatory operates its very large telescope. Running this technological oasis in the barren desert and making it a comfortable place for people to live poses many challenges. This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory, exploring the ultimate frontier with our host Dr. J, aka Dr. Joe Liske.
Hello and welcome to the ESOcast. Cerro Paranal, in the heart of the Atacama Desert, is one of the best places in the world for observing the night sky. But operating an observatory with more than 100 staff in such a remote and isolated place poses a real logistical challenge. It's like running a desert town.
Everything that is needed to make this Mars-like landscape a haven for people has to be brought in from far away. The most essential delivery to the arid desert is water. The observatory needs up to 70,000 litres of water each day, and literally every drop has to be brought in from the town of Antofagasta, which lies about 120 kilometres away. Everyone at the observatory is careful not to waste water, and it is recycled as much as possible.
In some ways, the Paranal Hotel, called the Residencia, is the heart of the observatory. This is where people come to relax and escape the harsh desert environment, and, very importantly, this is where the canteen is. Now, the quality of the food is absolutely crucial to everyone's mood and motivation. And so the catering staff at the canteen are working very hard indeed to keep everyone happy. Sometimes they even dish up a barbecue. But whatever they do, they always have to plan well ahead, because they can't just pop down to the shops. The nearest food suppliers, just like everything else, are about 120 kilometers away.
Once a week, an important transport arrives at the Residencia, bringing in all the food needed to feed 100 people. Throughout the year, some 200 tons of food are brought to the observatory. The kitchen staff must plan the meals carefully and make sure that all the goods that are needed are available on site, as there can be no last-minute shopping trips for this kitchen.
Now, the remote location of the observatory also means that it has to generate its own power. About 2 megawatts are required to run the whole observatory. That includes the telescopes, the cooling of the domes, the other technical facilities, as well as the hotel. In addition, to ensure the smooth running of the facility, it's imperative that the power supply is reliable.
The power plant at the Paranal Observatory. The plant is serviced at regular intervals to guarantee trouble-free operation. Like water, the gas needed to run the plant has to be brought in from the town of Antofagasta, and deliveries are made every other day. In the unlikely event that there is a problem with the electricity supply from the main power plant, a backup supply from diesel generators can be used.
Seeing Paranal from afar, amidst the stark desert landscape, it's incredible to think about the 100 people who live and work here. Despite all the amenities, life in a desert town is clearly a challenge.
There is a constant flow of people arriving and departing from the observatory. In addition to the ESO staff, about 2,000 guests, such as visiting astronomers and journalists, are accommodated every year. The associated logistics are hard work for the staff. A car is serviced at the Paranal Observatory. Cars play an important role at the observatory, as the astronomers and engineers often need to drive several kilometers between the Residencia and the observing platform of the VLT. The car fleet is serviced at regular intervals by mechanics. Paranal also has its own petrol station. The next nearest filling station is some 100 kilometers away.
As the sun sets over Paranal, it's time for us to leave the observatory. ESO has created a technological oasis in the barren Atacama Desert. Ultimately, it's a window to the universe, and astronomers from all over the world come to enjoy the view. This is Dr. J, signing off for the ESOcast. Join me again next time for another cosmic adventure.